All right. Notice how much
Nobody likes you.
Grayson, Alton, Cole, and Laura, notice how much quieter the people are in this classroom? That's because we're in fourth period now.
We're not really that quiet.
Yes, you are. Okay. So, what was the first one? So we're going to go over some questions today, and hopefully you actually look on Google Classroom like you said you would.
Hey guys, we're trying to prove a point here.
Hopefully, yeah, right. Hopefully you are listening to Google Classroom or looking on Google Classroom right now and looking at this video. So, Ellie, the first one you wanted to go over on the 6-2 worksheet was what? 4. Okay. So, and this is what we put in our toolkits the other day. If we are solving a system of equations, and remember, we can solve a system by graphing or by substitution so far, anyways. That's what we know so far. Okay? So our first step to solve a system by substituting is to get x or y alone, or whatever variable. You just have to pick one. If I look at this, I see one step in one of the equations that I can do and solve for one of my variables. What one would that be? Kai.
Divide x and 1 by 2.
Divide x and 1 by 2.
The top.
Actually, I have an easier one.
No, that's what he said.
Would be to subtract 1 from both sides and get 2y minus 1 equals x. Then you have no fractions. And I will. But I want to make a point. And my point is, if I took that and substituted that in for x, I'm not going to have any fractions to work with. So there is an easier way. So you might want to take a second and really think about what is the easiest variable to solve for before you substitute, because it can make your life a lot easier. Okay? But we can do that. We can do it the way you did it, just to see, so you can follow your work and see where you went wrong. So what did you do, Ellie?
I used the first equation and I divided by 2.
So you did what Ty did, and I get why you would do that, because we've been doing that so much with slope-intercept form and getting y alone that we're not really used to thinking about getting x alone, but we can. So obviously now we can figure that out. Remember, this is 1x, and we have to go 1 divided by 2, as well as that right there. Okay? So now I'm going to plug and chug, or I'm going to plug this in for y in the second equation. So where I see y, I'm going to put what y is equal to in the first equation. That's all substitution is. Take what y is equal to 1, put it in for y in the other one, and now I'm going to, once I do that, how many variables am I going to have? 1. That's the whole point. If I plug in this for y in terms of x, I'm only going to have x to solve for. Right? So now I can go and I can go ahead and just rewrite it by substituting it in. And I'm going to put parentheses here because of that naked negative. And I don't want to mess that up, so I'm going to put that 1 out there. And then I'm going to put the y inside, leave the negative on the outside. Because I have two terms here that I'm going to need to distribute to solve. Okay? So it does, you can see the problem becomes a little messier, but still definitely solvable. So I'm distributing a -1. Okay? And then I'm going to simplify. -2x minus 1/2 is -2.5x. I can make that a decimal because it is terminating. I can't always do that. I can add 1/2 to both sides. And I get -2.5x equals, I could even make that 7.5 again because it does terminate. I can change it to a decimal. And then I just divide by -2.5 and get -3.
I know where I went wrong.
Let me guess. Had to do with the sign.
Yeah, I forgot to put the negative on the 2x.
Funny how I know these things.
Mr. Pillow, no.
Well,
Wait, don't go.
often, not all the time, but I have a pretty good hunch often based on my 22 years of teaching math and the mistakes students make. That's okay. You get to learn from those. Okay, so if I plug in -3 for x, what's -3 plus 1? -2. So let me do this. I'm not going to take anything for granted. 2y equals x plus 1, right? So now I'm going to plug this into the first equation. 2y equals x plus 1. But instead, I'm going to plug in -3 for x. Okay? So I'm going to go 2y equals -3 plus 1. So I'm just plugging this back into this equation for x. 2y equals negative 2. Divide by 2, and y equals negative 1. What is the solution? Negative 3, negative 1. If I plugged and chugged the check, I would realize it works. Pack it in. Okay. What else? 6? You guys want to do 6? Okay. Well, I mean, again, for those of you who are a little unsure on substitution, hopefully these 3 problems will help you out. And then we have y equals 1/2 x minus 7/2. Is step 1 done for us?
Yeah.
One of the vault variables to solve for, right? So why make more work? We have to deal with fractions, but they're simple fractions. So I'm going to plug this in for y in the top, or substitute. Okay, so 2x. And then I'm going to do plus a negative here, and I'm having a hunch already that this may be where you made a mistake. So I'm going to do that negative 3, but because I'm only plugging in for the y, and in place of y, I'm going to put in what y is equal to in the bottom equation. Okay? Now I'm going to go ahead and simplify by distributing, and this is lots of really good practice on things that you worked on in the past and you need to continue to practice. And then we are going to simplify by combining like terms. 2 plus 1 and a negative 1/2 is 1/2. So I'm going to combine these two. Plus 10/2 is 13. So halves are always nice to work with, most often. And then I can subtract 10/2 from both sides and get 1/2 x equals 2/2. So x is 5. Okay? Because if I multiply both sides by the reciprocal, okay, well, what's 2/2? It's 5 halves. And what's 5 halves times 2? 5. Okay, so x is 5. Usually, if you're like, oh man, that was a lot of work, don't stop and don't psych yourself out because you've done all the hard work. Now it's easy. So I'm going to plug in 5 for x into the first equation. So I'm going to have 2 times 5, or my x, plus a negative 3y equals 13. 10 plus negative 3y equals 13. So even though the problem had fractions, we are going to get whole number answers, which always makes us feel a little better for whatever reason. So y equals 3. Right? So we get 5, negative 1. And I think when you guys see elimination, you're going to be like, okay, now that we have 3 different ways, we'll look at that on Monday.
Is elimination an easiest method?
Depends. In some situations it is. Depends. There isn't, let me put it this way. If you see a problem, there's definitely if you use one of the methods, it's going to give you the least amount of work for each particular problem. So if I give you a problem, okay, and we looked at it, I could say, what would be the easiest way to solve this? And you can either determine graphing, substitution, or elimination. We'll talk about it Monday. Anna?
So with substitution, we can solve whichever variable first.
Yes.
We can switch the equations around.
You can what?
Like switch the equations around, like solve for
Absolutely.
y in the first one.
Yeah, either one and either variable. Sure. Number 9. All right, so we have number 9, y equals negative x over 2 minus 4, I think, and negative 2x minus y equals negative 5. So again, step 1 done? Is step 1 done for me?
Yeah.
Sure. Will I make it harder? I don't like to make it harder. Keep it simple, silly. So I'm going to plug this in down here. Oh, make it negative. Everyone I've done today has a make it negative or a negative coefficient of my variable that I'm going to plug into. So I have a feeling that might be a really easy mistake you guys can fix by really focusing on that the signs, okay? Because other than that, process is the same every time. We substitute, we isolate for one of our variables or solve, we substitute, and then we go ahead and simplify by distributive property. And we could put a 1/2 there if we want, okay? Then we can simplify more. What's -2 plus 1/2? -1.5 or -1.5, right? And then we would subtract 4 from both sides, and we get -1.5x equals -9. Divide by -1.5, and we get 6. And you very likely could have gotten -6. If you divided wrong there, I lost the sign. If you distributed wrong, you would have gotten something totally different. Again, look at all those places you could have made a mistake. So you just have to be really attentive to precision, mathematical practice number 6, all the way along. So now that I plug 6 in for x, I can plug it into the second one. -2 times 6 plus a -y equals -5. -12 plus -y equals -5. I would go ahead and add y just because I feel like it. And add 5. I don't have to worry about that negative. Okay, so I get -7 for y and 6 for x. You know where you went wrong, Alexis?
Question.
Sure.
Why wouldn't you, because x is over 2, why didn't you do 6 divided by 2 minus 4?
Because I didn't plug it into that equation, I plugged it in the other equation. When we solve for x down here, right?
Yeah.
When we plug back in, I plugged it into this equation.
Oh, not the one up top.
See,
Okay.
right here.
Oh, yeah, that makes sense. Okay.
Anybody else? Okay, how are you feeling about substitution now?
I think I
Okay, well, you know, very not good.
Still iffy on it.
Really?
Yeah.
Okay, well, here's the good news. I mean, you have 12 minutes, and I really want you to get into it, and because the best way to feel more confident is to practice and do it right? And you do 2 or 3 right in a row, and you're like, okay, I got this. So don't let the ones that have fractions or negative that throw you off make you think you don't get it. A lot of times it's because you're tripping over things from the past, not because you don't get it.
Oh, that was my. Oh, I got it. Damn, the book for.
But now are you kind of seeing the whole thing? Really? All right, so you guys ready to practice?